This podcast is brought to you by ProcessBarron. Handle everything better. Welcome to Powering the Process, the podcast focused on the real work behind industrial manufacturing. Each week, your host, Jen Little, digs into the systems, equipment, and strategies that keep plants running efficiently. From everyday operational challenges to emerging engineering solutions, we're here to share practical insights that help you keep your process moving. Let's get started.
Welcome to Powering the Process, where we dive deep into the innovations that keep America's industries moving. Today we're taking you inside the ultimate fan experience, and I'm not talking about sports today. We're talking about the massive industrial fans that power critical processes in pulp and paper, cement, steel, and energy production. These fans aren't just blowing air, they're the heartbeat of entire operations. And behind them is ProcessBarron, a leader in the engineering, manufacturing, installation, and maintenance of fan rotors that keep these plants efficient, safe, and sustainable. Today our guest is Mike Piazza. He's Director of Air Handling here at ProcessBarron. He has over 30 years experience in the industry and almost 20 years here at ProcessBarron. Thanks, Mike.
Thanks
glad to have you here today.
Yeah, thanks for having me.
So we're going to talk about fans and how ProcessBarron plays an integral part in all the industries that we've mentioned. But I guess we can just start with, why are the industrial fans so critical to the heavy industry operations?
The industrial fans are literally the heart of the industrial air movement process. They're the pump that moves the gas, the air through the system. So they are literally like a heart. They evacuate systems, transport combustion air, induce a draft or force a draft through a system. So they're responsible for all of the airflow through the system.
So how do the fans impact efficiency and reliability in those industries?
So as far as efficiency goes, fans can affect the efficiency of not only the fan itself, but of the complete system. A fan that's not properly sized is a direct cost to a plant. It shows up in operational cost as inefficient use of horsepower and power consumption. And it also can cause the system to not perform optimally. So it'll perform, but not as well as it should be if it's inefficiently designed. As far as reliability, an unreliable fan is really not good for the system. It causes forced outages. A forced outage goes beyond the cost of the equipment. It goes to lost production time and loss of productivity, maybe delays in delivery of products.
Mm-hmm. And I know, so out there, people that are familiar with the industry realize that the kind of fans we're talking about are massive industrial fans that are upwards of 100 inches diameter, can weigh 40,000 pounds easily, and can only fit one on the back of an 18-wheeler.
Right.
So these are massive pieces of equipment which actually fit into housings. So the housings are even bigger than the rotors themselves. So it is a massive piece of equipment. Very, they're designed for their application. There's no two applications that are exactly the same. They may be categorized. We've got ID fans, we've got FD fans, we've got this fan, we've got that, but the specifications are different, right? From mill to mill, so, or from application to application, depending on their processes and their outputs. So for your group, what goes into designing one of these fan rotors? How do you get started?
So, like you said, every process is different. So we start by looking at fan performance. We have fan lines and software where we can select the optimum fan for the job based on the performance. That's the volume, pressure, at the temperature required, and handling the material that's going through it. And we have specific fan lines that are designed. Some are designed to handle material or for dirty applications, and some are designed for higher efficiency, clean applications. So using our experience in the industry, we select the fan and design it based on that individual application.
Okay. So knowing that, once you get all that information, I guess then we can send people out to test a system, right?
Correct.
To
Yes.
to bring back that information, because that's not something that we want to test it for ourselves and gather all that data ourselves,
Right.
right?
So what we receive, we receive information two different ways. We either get design conditions from an engineering firm or a designer who's setting up the system, and it'll be predicted information, or we will get actual field tested performance from an existing system.
Okay. Then so once we get all that information and we know what we know where we're going, we've got fan curves, we've looked at fan styles, we know which design works best for their application. So how do you balance performance, durability, and cost?
That's a good question. So, like I said, fan selection is based on performance. And we do have, as far as durability goes, for the same fan performance, we may have a design that's more suitable for material handling or dirty applications, and we may have a design that's more suitable for clean air applications, and both would fit the application as far as performance, but not as far as durability. So we select the fan based on that particular application to meet the requirements of the airstream. So if it's a dirty application, we'll select a fan that's easily armored, that can handle build-up, and will just be a heavier construction in general.
Right. So what is the most common material for fans?
So we do just about any material. Our minimum material is a 50,000 PSI material, A588. We use that as a minimum. We go up from there for higher strength. We look at the stresses in the wheel. If we need a higher strength material, we use A514, which is a 100 KSI material. We also fabricate based on the need. We use just about any kind of wear plate material, any kind of alloy for corrosive environments. We've got welders who can weld just about any type of material.
Awesome. So in all your years here at ProcessBarron, is there one particular challenging design issue that sticks out in your mind?
Not one particular. We do see some challenging design issues. We have a common issue that we deal with regularly. It's challenging, and it's placing wear material on existing equipment.
Okay.
So, like I said, with the new design, we design it or engineer it for the application. It's already, we start with a blank page, come up with a new design, make sure it's engineered to fit the application. A lot of times with existing equipment, we have to change the design or there are changes in the process that require the addition of wear plates to extend the life and durability of the equipment. And that's one of the most common problems. It's usually not as simple as just adding wear plate material. We have to do additional engineering. We have to make sure that the additional weight and the additional inertia don't affect the integrity of the wheel, the shaft, or affect the way the motor starts it. So there's a process we go through and pretty much re-engineer the wheel to make sure we can offer a solution that extends the life of the equipment.
Okay. Well, so I know we have an inspect and advise process here because we have thousands of rotors in the field. So at any given time, any of our customers could have a problem with that rotor, or they know they need a spare in the laydown yard. Or maybe it's just time. You know, they want to turn the one that's in service into the spare. They need a new rotor, that kind of thing. So a lot of times the customers will send us the rotors. We will bring those out of an outage, sometimes if we're doing a wheel change out, and bring them here. So once they get here, can you explain kind of what happens in that inspect and advise process?
Sure. We have a pretty thorough inspection process. We'll receive the rotating assembly in, clean it, sandblast it, get down to good material. Our QC team will set the rotor up in our inspection rig. We measure the shaft total indicated run out to make sure the shaft isn't bent. We inspect the journal areas to make sure there's no obvious damage to the journals. We will MT, mag particle test, or dye penetrant test the wheel to make sure there are no cracks in it. And then we'll check for obvious wear of blades, loose components, anything missing, and then we'll produce a proposal for any repairs needed.
Okay. And I know it depends, the turnaround time depends on a lot of factors. The material of the rotor. Does it need a new shaft or not? If it needs a new shaft, does it have to be forged? All of those things. So when we send a proposal back to the customer, we've explored all of those things. So
Yes.
we can definitively say, we can remake your wheel or recreate your wheel. Doesn't have to be, we do inspect and advise on any wheel from any manufacturer, correct?
Correct, yes.
We
do.
can reverse engineer.
We can reverse engineer and we can reuse components. A lot of times we get rotating assemblies in that need minor repairs. We do anything from just cleaning, inspecting, and balancing the rotating assembly and sending it back, all the way to re-engineering it, reverse engineering it, and providing a complete new rotating assembly.
Okay, I know that's a valuable resource that we're able to provide our customers a lot of times. Now, I know we've all run into that issue where there is that, all of a sudden there is that failure. Rotating assembly failure. Wheels going down, boiler's going down, and then we're mobilized to go get that. And there's no spare on site. So then we're in that, the customer is in that position where the wheel they need has to be, we have to start from scratch a lot of times. And I know that you've had to deal with that quite a bit. But can you speak to a little bit just how our manufacturing facility between your group and engineering and manufacturing can all come together, and how we're able to I guess, pull off a miracle sometimes for our customers?
Well, we have a great team. So
Right.
we've got a lot of experience here with manufacturing, engineering, estimating. We've got a good group of people who can come up with a good solution quick and turn around a solution and a repair, get it back to the customer as quick as possible. To start with, we have an engineering team that can reverse engineer, produce drawings, get them in the shop quick. We have 2 shifts out in the shop that work just about around the clock, so we can put the manpower on the equipment when it's in the shop to get it fabricated. And we also stock a lot of our materials, the A514, A588, some of the stainless steels and alloys we keep in stock, as well as shaft material. So we do keep some of the smaller sizes in stock, and we also have a few large forgings that would normally take 8 to 10 weeks to get in. We stock round bars. So we can normally turn around equipment quickly.
Okay, I know that's one of the things that sets ProcessBarron apart in the industry is our availability, our ability to respond, and our ability to turn things around, get the equipment back, and get our customers back online. I know everywhere I've been in the field, they've all said the same thing, and it's our response, and it's the ProcessBarron way to respond to those emergencies on those critical pieces of equipment.
It is. It was the origin of the company. We got started in the fan repair, rebuild business, quick turnaround. Mm-hmm. It's basically what the company was built on: customer service, quick response time.
Mm-hmm. So over the years, what is the most common issue you see when the rotors come in to the shop? Maybe we've taken it out, on a change out. Maybe it's just a spare. But what's the most common problem you see?
We see a lot of bearing failures. So a lot of the rotating assemblies we get in have shaft damage from poor bearing maintenance or bearing failures.
Right. So a more rigorous preventive maintenance schedule for the mill would definitely help mitigate that some, right?
Absolutely.
Because the bearings checkout would be part of the PM inspections.
Absolutely, yeah. Bearing change-outs in the field are usually quick, don't cost that much, but when you lose a fan, it's always at the worst time.
Right.
It's always at the highest production time, before a holiday or
right.
on a weekend.
Right. And then a lot of times, depending on the industry, but when one of these plants goes down, it's a loss of, could be hundreds of thousands of dollars in a day.
Yeah, usually the equipment cost is minor compared to the loss in production and installation cost.
Right, right. So how do you think technology now is improving with fan rotor design? When you started out 30 years ago, I'm sure things were a little different then. So what kind of technology has made the job, I guess, easier and more accurate over time?
A lot of the computational analysis has helped over the years. It goes for fan performance as well as structural design. So we're able to model airstreams, predict wear patterns, and design wheels to fit existing applications based on what the process is currently doing. We're also able to predict performance upgrades. If we're going to try to upgrade a rotating assembly, the computational design, using the computational design, we can verify the performance of the rotating assembly in the existing housing.
Right, okay. So in that way, it's possible to save the customer a little bit where they can upgrade their fan, not have to change the housing.
Correct.
Part of it.
We can put a new rotating assembly in an existing housing, upgrade the performance, either give them more performance or more efficient performance, or both.
Yeah, okay. So I know ProcessBarron itself has been through many innovations over the years, over 45 years ago when we started out. Very small company, just concentrating, like you said, on rotors. But over time, we've added product line after product line. But here recently, there's been one safety innovation in the air handling department, the safety brake. Do you mind touching on that just a little bit and tell us a little more about safety brake?
Yeah, safety brake is a braking system that can be installed on existing fans, or with new fans. It's easier to put on new fans, but we have applications to put it on existing fans. And it's pretty much a brake system that allows the customer to control the speed of the fan, slow it down rapidly, stop it. lock the fan rotor out to prevent it from freewheeling while maintenance is being performed on it.
Mm-hmm.
So it's a brake system and a safety device.
It's awesome. I know that came out of several years, I think, of ingenuity, a little bit of been there, done that kind of thing, just years of experience that have gone into the creation, I guess, of that device. And I think it will prove to be very profitable in the coming years. And like you said, it is a safety device, probably more than anything else. But I really think that those could be used in any industry. I think they're predominantly used in the steel industry when you've got parallel fans.
Yeah, we mainly use them in the steel industry, baghouse type applications,
mm-hmm.
where you have multiple fans operating in parallel.
Mm-hmm.
And in any case where one of those fans may be shut down while the others are left operational.
Mm-hmm. Okay. So over your 30 years, like we said, things have changed a little bit. Where do you see fan technology heading, say, in the next decade?
Fan technology is kind of old and unchanged. I guess we're applying new technology to the older designs of fans.
Mm-hmm.
One instance would be using Bluetooth monitoring systems for vibration and temperature.
Mm-hmm.
So at one time you had sensors that were hardwired into a control room, and you had an operator in the control room who monitored the health of the equipment, looking at vibration and temperature levels. Now with wireless technology, we're currently using wireless sensors. And you don't have to be in the control room. These sensors can send trend data to your handheld device, your cell phone or tablet, and also send alerts and for any kind of upsets in performance.
Mm-hmm. So it's more, is it just kind of makes it more real-time information?
It's real-time information, and it's available whenever you want to look at it.
Mm-hmm.
And instead of having to call the mill or call the control room, it's something you can look up on your own device.
Oh, okay. So we've had the privilege of working together for quite some time. And if you had to sum up the culture of ProcessBarron, just a couple of words, how would you describe it, Mike?
We are a very close, customer service oriented company. Mm-hmm. It seems like we focus more on customer service, and
it's hard to say. I know. I try to say it's
is.
like we're a big company with a small company feel.
Yeah,
right.
we are.
But very customer centric, and I think that's one thing when we have new talent come in, and the younger generations, like, of course we can say that now, and they come into different departments. I think one of the most important things that we convey well is the importance of the customer's needs, what the customers are actually doing, why they are our customers to begin with, why these industries are important, and what it means when they're not operational, and what it means big picture. So I do think that that's important. And I think our customers feel that too, because we don't just have customers, we have partners.
Yes.
And we have been in partnership with a lot of these facilities for decades. And I think it has a lot to do with the people inside this building and inside those shops, and how they it's not just the product that they turn out, it's how they do it.
Yeah, we built relationships over time with quite a few companies.
Yes, absolutely, Mike. Well, we're going to wrap it up here, and I just want to say thank you so much for participating in this, kind of explaining to everybody what the ultimate fan experience really is and how ProcessBarron plays a part in that.
Well, thank you for letting me be a part of it.
Of course, Mike. Thank you.
Yeah, thanks.